All right, 10.1. We've already been here. We've already done this, but we didn't get to finish the last example. So calculators out, degree mode ready for us to finish that last example. And as we build up to that, we're going to review real fast everything that, well, either you did do homework on or you're going to do tonight. Okay? The biggest new thing that comes up, well, two new things. The two big new things that come up is the word incline, or we can say inclination, and that's how steep the line is, kind of. The angle at which the line would go to a horizontal. So this one, the angle is 0, even though it's off the 0 angle mark, because its curve or its slope is 0. So these don't have to be at the origin. They don't have to be at a specific spot for us to measure the inclination. We can say, how steep are you? You're flat. Okay, cool, 0. How steep are you? Okay, some sort of acute angle, some sort of positive slope, some sort of obtuse angle, some sort of negative slope. And then a 90-degree angle, you will die slope. But we talked about this important formula that ties together inclination with tangent with slope. The angle of incline, the inclination, the tangent of that angle. Tangent equals slope. And this is a huge relationship in calculus. Now, it doesn't seem to make a lot of difference now because it's like, whatever, a line has a constant slope, rise over run, no big deal. Choose any 2 points and subtract and take a fraction and you're good. But as soon as we get to curves and we're talking about slopes at curves and rates at curves, it starts to get really tricky unless we understand that slope and tangents are tied together. Anyway, we'll stop for right now as far as that relationship. But inclination is a new one, bless you, and tangent being related to slope is a new one. Now we talked about how standard form is really nasty. You probably want to get it into slope-intercept form to find your m's, maybe 1 m, maybe 2 m's. But then you can plug into formulas using things like tangent inverse to get to angles. You can find them in degree mode. You can find them in radian mode. I think the book probably had both answers, degrees and radians. But I'm sure even if you did do homework, you probably don't remember. We'll see it when we look at our answer key tomorrow. But then there is one more concept, and that was how to find the angle between. And this was the example I don't think we got to finish. So if you guys can go find this formula in 10.1, if you can go find the example that we started. I don't have it finished up here. Maybe you finished it because you were ahead of us on Friday. But let's go ahead and get this example all solved out and finished. And then you guys should be good to go to finish up homework if you have not yet already for tomorrow. And we can go into section 10.2. So in this formula, if they're asking for, like these directions, find the angle. The angle is theta, right? And specifically the new term, it's the angle of inclination or the incline between. But we'll just say angle between. What was the very first thing I had to do to get this m to even plug into my formula? Yeah, to get in slope-intercept form, aka get y by itself, right? So some legal algebraic moving around. I did the exact same thing here, but I did it really fast on Friday. But you guys, most of you would have had to go step by step of like subtracting the 3x. Dividing by 4, not just the negative 3x, but also the 12 had to be divided by 4. But once we get the y by itself, slope-intercept form, we can steal the m, we can throw into our formula. So our formula says m2 minus m1, which technically, as long as you plug them in the correct order, because of this absolute value, it actually doesn't matter which one's which. So there's no magical who's M1, who's M2. Just pick one. He's M2, he's M1. Fine. He's M2, he's M1. Fine. It doesn't matter. You don't need to stress about the order. But long story short, we need to subtract the 2 m's. We need to divide by 1 plus multiplying the 2 m's. And that's what I was kind of in the process of doing down here. Wait a minute. No, I didn't do any math, right? This is still negative 3/4 minus 2. I didn't do any of that. And then this is still 1 plus, and I didn't do any of that. What was the difference between this one and this one? Oh, yeah. And how do you move tangent? Tangent inverse, not dividing, not weird square rooting, but tangent inverse, right? Lauren? Well, all because of the directions. Do you remember what the directions said we were supposed to find? And the angle means the theta, so I had to get theta alone. Does that make sense? So in doing that, why didn't I go any further? I could have. I could have been like mental math skills. I got them. I can simplify complex fractions. Can you? And I've done that this year. But why didn't I? Where are you going anyway? So can't you just do second tangent inverse? Or I should say second tangent. And then can't you do a nifty-difty fraction? Actually, pause. Maybe absolute value. Shouldn't we do absolute value first? We've done absolute value this year. How do you find that one, guys? You can go math. You can go math and over. Or you can do number 5. What's Jason talking about?
You go to math and then you go to complex and it's number 5.
Oh, you go to complex? I think I just go to number. I just go to the second one.
Oh, it's in both.
Oh, it is in both. I never noticed that before. I always just got it from the other menu. But you guys know where we get the shortcut fraction button, right? Using the alpha button. Have you ever tried to do alpha window? I feel like we've talked about it. Alpha window. Abs is right there too. Wish normal abs were that easy to get. And then go get your fraction. Boop, boop. There he is. And then you can plug in your negative 3 divided by 4 or negative 0.75 minus 2 all over. You guys got it? You tracking? Really quickly, if someone has not gotten 79.695, double check in your group really fast how to use your calculator because maybe you're a little bit rusty coming off spring break. If anybody has not gotten 79.695. Okay, better way. Those of you that did get it, check in your group and be like, hey, you guys good? What if the back of the book has another answer? Or it's in radians. So how could you get the radian answer? Because how do you change it? One is you can just change your mode and do the whole thing over again, which isn't that hard, right? You just go up and copy and paste it, kind of. True? What? That's cool. Never noticed that one before. Hit enter again. Go team. Huh. I didn't realize you could do that. I always scroll up and then I hit enter and then I go again. 1.391. But is there a way to convert without changing your mode? Not that you have to, but is it pi over 180? You could have also done dimensional analysis, which would have taken your 79.695 and multiplied by pi over 180. Because remember, couldn't your degrees cancel and you end up with radians? Just a few of you actually do that every time, so that's valid. I want to back you up and say, yeah, that's good, but you could just change the mode. It's a lot easier. So guys, this is what I mean by the back of the book could have degrees, it could have radians, or it could have both. I think it actually has both in this section, but either way, in case you want to know how to work that. Is this formula kind of hard to memorize? There's a lot of pieces to it, right? So I think it might be kind of complicated to memorize, but is it complicated to solve? Not as long as you remember 2 things. Number 1, how to use your calculator. And number 2, don't forget tangent inverse. If you forget tangent inverse, you'll be in some trouble, yeah? Okay. So as long as you know the formula, number 1, and you can use your calculator, and you remember the tangent inverse to get to theta, this shouldn't be a big dealio. All right, cool kids, keep a close eye on the directions. Make sure you know what's been given to you, because if you notice, we did 3 different homework helps for that one little baby formula before the hard formula. So the directions might get a little funny. Just be careful as to what you've been given. Go look at the examples and notes if you haven't tried homework yet. But otherwise, we'll be grading this one and going over questions tomorrow. But our job right now is to get into section 10.2. So where do you see the line? Because that was 10.1. Ah, he's a degenerate. Isn't that almost always a negative thing? You degenerates, right? It's usually like adults talking about kids. Anyway, I don't know if I've ever actually heard it in any other context besides right now. Yeah, that could make sense. Oh, that's true. It could just be like higher to lower and like a... Okay, I didn't think about that before. Guess I just never really heard it that way. But yeah, it would make sense. So what is it, or how does it apply in math? Well, conic sections. You guys remember these at all from last year? No? Ellipses? Hyperbolas? Now, you probably didn't see the double-naped cone thing and like, hey, slice it and you get, slice it and you get, slice it and you get. You probably didn't really see it that way, but I'm pretty sure you saw circles. X squared plus y squared is r squared. Ellipses, x minus a. Nope. Ellipse. There you go. Ellipses are like squished circles, right? Parabolas, well, we've seen those before. Hyperbolas, well, they're kind of like double parabolas. But then we have these degenerate guys. And these degenerates, do they have any curves in them whatsoever? A point? No. A line? No. Intersecting lines? No. So basic conics are all, well, they involve some sort of curvature, but degenerates, there's no curvature. But it's still slicing, just slicing in a weird way. If you slice straight through, you only get a point. If you slice along one side, you only get a line. And if you slice directly down the middle, if you slice away from the middle, you'll get these guys, but directly down the middle, you'll get intersecting lines. But anyway. What? Yeah, you can, if it's on the surface. Assuming you have surface area. You're talking about the whole, this has no depth. Is that what you're talking about? Yeah. Yeah, but a line doesn't have any space either. So yes, you could. Think about it. Okay, standard form of the equation. Whoa, 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 whoa. So all 7 of these can be written like this? That doesn't make sense. We know what a line looks like. Doesn't a line look like, we just talked about it, ax plus by is c? Right? That's not, well, this would be 0, that would be 0, that would be 0, and this and this and this. So I'm not saying all of these have to have a coefficient that's non-zero. They can have 0 coefficients. But a line can be written with this standard form equation if it's a 0 and a 0 and a 0 and then a dx plus ey plus f. That is a line. An x term, a y term, and a c. A point. I have to have 0, 0, 0, and then either that would have to be 0 with those two being a number, or that would have to be 0 with those two being a number. Well, a point would be a little more complicated than that. 2 intersecting lines you're not going to be able to see until we actually learn some of the other guys. A parabola, hold on, we know him. That's y equals x squared. That's easy. Yep. So that could be a number, but then that would be 0. That would have to be 0. That could be a number. That could be a number. That could be a number. For a parabola, we just need one of the squareds. But what happens if we have 2 squareds? Now, before we go any further, I may as well be super honest and open with you because you have this cool thing called, I almost lost it. A what? That has this cool menu called apps. And inside cool calculator, inside cool menu apps, there's also a cool option underneath the C's called conics. We're not talking about circles today. We're not talking about ellipses today. We're not talking about hyperbolas today. But what are we talking about? Parabolas. Number 4. Does this equation for a parabola look like the one that we learned at the beginning of the year, though? Sort of, kind of, maybe. The one we learned at the beginning of the year. Let me see if it's on the next page of notes or whether it's something I come up with on my own. Oh, no, it is. You guys might not realize it, but whenever I have anything in green, it's always review. Vertex form of a parabola. From the beginning of the year, we talked about how y minus k is equal to a times, x minus h, quantity squared. And we had to review things like completing the square. We also could write this another way. Y equals a times x minus h squared plus k. And this was the new standard form because most of you guys would have thought standard form was ax squared plus bx plus c. So whether you're used to this form or whether you kind of got used to this form, this is how we've talked about parabolas up until now. But what's true about what you see on your calculator underneath parabolas? I mean, pieces are the same, but aren't things kind of different? Like, who's this p guy that's randomly showing up, and why is there a 4? Now, if you guys really want to be tripped out, you can actually hit the mode button When you hit the mode button, you can change from func mode to par mode and then go look, escape out, and then everything changes. You can go to mode and go to pol, P-O-L, and then escape out, and everything changes even more. Parabolas can be written all sorts of different ways. So at least in function mode, if you're wondering how to do that, we're underneath the Conics app, we're in parabolas, but you're hitting the mode button in that option, changing it to par, P-A-R, and escaping out and looking, or changing it to pol, P-O-L, and escaping out and looking. Parabolas don't just look one way. You saw this one back in Algebra 1, and also in, I just crossed it out, and also in Algebra 2. But we learned this year that's not always the best way because you can't find the vertex just using this guy. You can only find zeros or factors using that guy. This form's so much better because you can find the actual vertex. You can find the little guy that's on my axis of symmetry that my parabola is about because that's my HK. You can find the little guy that my axis of symmetry is about. That would be a minimum if it was concave up, it meaning the parabola. The orientation all depends on whether my coefficient is positive. Oop, nope. Positive would be a positive person. They smile. They don't frown. Over here. Negative, here we go. Less than 0, concave down. But that's all review, even though that's how we've seen it. I mean, if I were you, I would go back to function mode now, because that's the one that we're working on. That's the one that we're working with. You don't have to worry about pole or parametric until Chapter 10b. But we do have this new formula. Super similar. Compared to all the other ones, it's way closer to this than any of the other ones are. But still, it's a little bit different. There's a 4 and there's a P. There's a 4 and there's a P. So before we end today, granted, we did have to go back to section 10.1 and logistically do some things that took some time. But let's go ahead and talk really quickly about who on earth this 4P guy is. The conic section form of a parabola. This is what your calculator is showing you, right? Is a little bit different in that it takes the coefficient, and instead of the coefficient being by the squared guy, he's actually by the other guy. That's one thing that's different. Instead of the A being over here, it's been moved over there. And instead of it just being an A for the whole coefficient, the A has been split up into 4P. So if, for instance, you were to have your vertex form of y minus k equals a times x minus h squared, to get to here, you'd actually have to divide your a first, which you could write that little 1 over a over here. But then you would have to take that little 1 over a and say, hey, you're supposed to be this 4p guy. So then p is going to always end up equaling 1 over 4a, which is a relationship, and you could totally memorize, except the problem is it just gives you something extra to memorize, and that's not always so fun. So maybe it's easier just to realize, okay, we're going to have to do some work to figure out this p dude, and we're going to work on that tomorrow. We're going to work on that tomorrow. But what I want to show you really fast is what he is for. The P guy, go ahead and pack up. The P guy is how far away the vertex is from what we call the focus and what we call the directrix, which you might be like, they don't seem very important. I've never talked about them before. Until you realize that every flashlight has a parabolic reflector, and the light bulb has to go in one specific spot so that all the light is focused along a beam. Bye, cool kids. I'll see you tomorrow. 10.1, have it ready to grade. Thank you for your patience. But remember, if you ever have a question in the future, email me. Bye.